come here 2.5 hours. Yesterday, we are going through some of your answers. I can calculate about X term of your answer. Okay. PDO circle, you enjoy it now? Yes or no? No, yes, you do enjoy it. Okay. Now it's not the end yet. Okay. So now we're going to deal with shearing stress. Shearing stress is the most difficult topic in structure analysis. Okay. So what? You asked in the lecture already, yes or no? It is the most difficult, okay, and it's the most confusing. And I find it confusing. So when I start teaching this in 2016, I find it really, really confusing. And I start doing 30 over questions, and I summarize the context of shearing stress that you find so easy. I will guarantee you that. If you ask any of you in civil, have friends in civil engineering, go and ask them. And when they see what you learn, they will see, holy shit. Okay. They were like, whoa, not seen this before. But you will be able to analyze any structure. Okay. So in context of shearing stress, where are we? You all need normal stress, yes or no? You all know how to calculate question number 3. Look at one of the worst loading situations. You all calculate your normal stress. When I look at the question, your answers, a lot of it get it right. So you get it, that's good. Now we are going to incorporate what? Shearing stress. After we know shearing stress, can you still imagine the element? By the way, I clean up my math. Okay? So the story is, whatever thing that you do wrong, make it right. Are we clear? Even at my age. Okay? Another time I was speeding, what will happen to me? I have to go to driving school. It's that bad. Okay? And road rage. No, I don't do it. Okay? So today we are going through the mechanics of shearing stress. I know you have a math test coming. Don't feel like copying. Okay, you want to study math, go for it. Okay? I will write and we'll start from there. Okay. So we have to understand the mechanics of shearing stress. And I did not know, did Dr. Koshi derive any equation? Did Dr. Koshi derive any equation in shearing stress? So have you all found this relationship? So today, it's not just applying a formula. We are going to derive, okay, that shear xy is equal to shear yx. And this will be equal to 3 over 2. And then we will have Vy over A. And then we have a form that we have y minus y squared over c squared. Okay. So we are going to derive this formula. And from here, what we do now is, what does the structure look like? Or how can the structure look like? So if the structure now is a built-in structure, so you have a built-in structure over here. Yeah, my drawing's a bit crappy today. And this built-in structure has a load P over here. And then we have our transformation. This is X, this is Y, and this is Z. Okay. So from here, we know when we have a cantilever beam, right, at this surface over here, this is where fracture will occur. Okay, if it's going to break, it's going to break at a plane. So the fracture plane, if I'm going to look at the fracture plane now in 3D, all right, this is the plane of interest.
So this is X, Y, and coming out is our Z. So now this plane, right, intersect this plane over here, right, this line. So it's our X. And the shear force, P, this is equal to Vy. Okay, so we know that the shear stress is coming down in this direction. Okay, so where is this direction? So we know that this is shear, the intersecting plane is X, the shear force, the shear stress is coming in the Y direction. Okay. So I'd like to draw your attention to this diagram over here, which you all have. Can you copy and paste this diagram on your notes? And we are going to rely on this diagram heavily now. I repeat again, we are going to rely on this diagram heavily now. Now, up to today, when I see a diagram like that, I still take it like whatever. Okay. Did I tell you about my sister yet? Have you heard about my sister? My sister, her name is Eileen, and I'm Eugene. Okay? She's 2 years older than me. One of the best teachers in Singapore. Unlike me. When we were young, the grades was the top 2%, like most of you. You want to know how I did in my elementary school and high school? Bottom 2%. Okay? So whenever there's a parent-teacher's day, my parents were volunteer, so cannot wait to go to meet a teacher. When it's mine, no one wants to attend. It's like I'm orphan. Okay? But my mom, they go to my dad, and my dad, they go next year. Okay? And I asked her a math question. Okay? And I don't understand what she's saying. And she told me this, brother, math is a language. You know what I like to tell her? And I was 11 years old. You know what I tell her? Big bitch. And I beat her finger and make her cry. After that day, my mom said, you're not going to ask your sister anything. But you know what? She's right. Math is a what? It's a language. Right? I know you guys will say, crazy bastard. What are you talking about now, right? And when you grow older, you appreciate. Now, I want you to draw your attention on Y and Y bar. Yeah, I want you to draw attention on Y. Y is measured on the horizontal axis Z. Yes or no? Y bar is also measured from the horizontal axis Z. What does that tell you? It shows that the centroid Z on the Z axis is your what? Theta. You think that? Oh no, you see the no, it means something. Okay, it's not like I think it's okay. So now we know, right? Now we know, okay. Over here, right? This thing over here is known as our datum. And our datum correspond to the geometric centroid. Highlight over here, geometric centroid. Okay. So the first thing that I like to highlight for you, okay, so if you were to tell me, Eugene, how will you change this diagram? If I were to change this diagram, I'll draw the arrow going this way. Right? And you all did engineering drawing before, yes or no? When did you do your engineering drawing? Could you remember? Last year, right? in 1P whatever, right? The one course that got 13 units and whatever. Okay. And this is the sign for, I'll not call any name. This is the sign for datum. Okay. So we know that that is our geometric datum. Okay. And then the shaded region is A, is the area of interest or area of concern. So you are interested in that area. Okay. Now, Y over here, or Y bar over here, is the perpendicular distance perpendicular distance to the centroid of the area of concern. Okay. So you can see over there, right? C prime, this point over here, is the centroid of the area of concern. Okay. So Y over here, you will see another symbol. So Y over here, right? It is the small y is the small y is the distance between the global centroid to the area of concern. Okay. So y over here is your variable. So you decide. So y is the what? Variable, which is decided by you. Okay. You decided what you want it to be. Okay. Now, after you have seen all this, we are going to write out the general formula. Okay. So the general formula is shear xy is equal to Vy over Izz Qz over T. Okay. So now, rule number one. Okay, we are going to write, wait, let me see, is it rule number? I've written so many rules. Okay, rule number one. Now, there are 7 rules. You cannot break any one of them. Break any one of them. Clear. But if you do break some, you still go to heaven. Clear. Okay. Okay. So you cannot break any of them. Okay, but you can still go to heaven. Okay, so rule number one. Okay. It's important to note that Vy and Izz, okay, or I won't call it Vy, it's important to write V and I, okay, it's like my girlfriend V, but anyway, V and I are constant regardless of